Dear children, welcome to my channel Learn Science with Usha Raghupati and welcome to watch my video lesson on acid, bases and salts, chapter 2 of class 10 NCERT science textbook. In this unit or in this chapter, we will be learning the reactions of acids and bases and how acids and bases cancel out each other's effects and many interesting things which we see and use in our day-to-day life. This is part 1 of this unit, and in this video lesson we will be mainly dealing with the reactions of acids. If you like this, please subscribe for more video lessons and click the like button. Children, in order to know whether a substance is acid, base or a salt, we should first know what an indicator is. What's an indicator? An indicator is a dye that changes its color when it is put in acid or a base. The three common indicators to test for acids and bases are litmus solution or litmus paper, methyl orange, and phenolphthalein. Now let's see what happens when blue litmus is put in an acid. It changes its color to red. Whereas when you put the blue litmus solution in bases, no change in the color. The same with a neutral solution. Now let's see what happens when red litmus solution is added to an acid solution. There will not be any change in color, and whereas when you put red litmus solution with a basic solution, it changes to blue, and there will not be any change in color in the case of neutral solution. What about methyl orange? Methyl orange changes to reddish pink in color in acid solution, yellow in basic solution, and orange in neutral solution. And phenolphthalein becomes colorless in acid solution, changes to pink color in basic solution, and becomes colorless again in neutral solution. Here you have another interesting experiment, dear children. This experiment is to test the samples with olfactory indicators. Now, what are olfactory indicators? Olfactory is related to your smell. So, I have given you here 3 examples of olfactory indicators. They are onion, vanilla, and clove oil. So, olfactory indicators are substances which change their odor or smell when added to acidic or basic solution. So the experiment is like this. Take some chopped onions in a plastic cover along with some clean cloth strips and put it in the fridge overnight. Take it out next day and check the odor of the cloth strips. You know, onion has got one characteristic smell. So now the strips will be smelling of onion. Now spread these cloth strips on a clean table, and what you should do, add a few drops of sodium hydroxide solution on one strip and a few drops of hydrochloric acid solution on the other. Now rinse both the cloth strips and again check for the odor. The cloth strip where you had put sodium hydroxide, the onion smell would have disappeared. Whereas the cloth strip on which you had added or you had put acid, hydrochloric acid, the onion smell remains on it. So this proves that This onion retains the smell in medium, acidic medium, and loses its smell in basic medium. The same is in case of vanilla extract, which has got a very pleasant smell, and clove oil, which all of you would have smelled. They both, if they're added to acidic solution, they retain their smell, whereas when they're added to basic solution, they lose their smell. So this proves that the sample which is given to you is acidic in nature or basic in nature. Let's understand some general characteristic properties of acids, dear children. What are they? The first one is sour taste. Most of the acids are having sour taste. And the next one is the action of blue litmus on blue litmus paper. If you dip blue litmus paper in acidic solution, it turns to red. You observe from this picture. And the next one is the action on methyl orange. What happens? When methyl orange solution is added to an acid, it changes to reddish pink. And the last property of an acid is most of the acids are corrosive in nature. That means they give burning sensation to the skin and make holes on the cloth in which they fall. Dear children, let's find out what happens when acid reacts with metals. This is an interesting experiment. I wish you had done this in the lab. But anyway, let me explain this to you. Now, I am not going to tell you the aim of this experiment. We have to find out why did we do this experiment? Why did we learn about this experiment? The experiment needs the following materials. See the picture. You need a test tube. You need dilute sulfuric acid, zinc granules, a delivery tube, a trough containing soap water, and also a test tube stand to hold the test tube, and candle matchstick. Now you take dilute sulfuric acid in the test tube and add zinc granules. Immediately you can see a brisk reaction taking place and some gas has been evolved. Now, which gas is this? We have to find out, isn't it? So this gas is passed through the delivery tube to the soap solution. Immediately what happens? A lot of bubbles come up in the soap solution. The bubbles, as they come up, you have to show a lighted candles. They're all air gas filled bubbles. So the lighted candle is showed near the bubbles. The bubbles burst. The gas in the bubble will be burning with a pop sound. It gets ignited with a pop sound. So obviously this will be the hydrogen gas. So what happens? Now why did we do this? To find out what happens when acid reacts with metals. So what is formed? Hydrogen gas is formed along with the salt. Now see the reaction here. Zn plus H2SO4 gives ZnSO4 plus H2 hydrogen. So this is a typical reaction of an acid with metal. Dear children, yet another experiment to show that acid reacts with metal carbonate to liberate carbon dioxide gas. So the materials needed for this experiment includes 2 test tubes, lime water, sodium carbonate, dilute hydrochloric acid, test tube stand. That's it. Now you have to add, you have to take the test tube and add sodium carbonate, 0.5 grams of sodium carbonate, and to that 2 ml of dilute hydrochloric acid. The reaction takes place and a gas is liberated. Pass this gas through lime water. So the lime water turns milky. Obviously, the gas is carbon dioxide. So the reaction is as follows. Na2CO3 plus HCl gives NaCl plus CO2 plus water. The same, if you take sodium hydrogen carbonate also, the same thing happens. NaHCO3 plus HCl gives NaCl plus CO2 plus H2O. So the conclusion is when a metal carbonate reacts with an acid, carbon dioxide gas is released with the formation of a salt and water. Oh, yet another most important reaction of this unit, that is, how do acids and bases react with each other? Here, the aim of the experiment I am going to give. What happens when a neutralization reaction takes place? That is the aim of the experiment, to find out the neutralization reaction between acids and bases. Now you need dilute sodium hydroxide, dilute hydrochloric acid, and a test tube and phenolphthalein indicator for this. Now take dilute 2 ml of dilute sodium hydroxide solution in a test tube and put 2 to 3 drops of phenolphthalein solution. Wow, a nice pink color solution we get. So the phenolphthalein is an indicator which indicates that there is a base in the test tube, so that it changes its color to pink. This already we learned at the beginning of the lesson. Now, in this test tube, add dilute hydrochloric acid. Oh, the pink color of the solution turns colorless. Why? Wow, what is this? So, a reaction has taken place between acid, that is hydrochloric acid, and sodium hydroxide, and a salt is formed with water. Now, why this colorless nature of the solution? We have to find out. Because the acid has neutralized the base. No more sodium hydroxide is present in the solution now to get reacted. It has been neutralized. That's why the phenolphthalein changed the color of the solution from pink to colorless. So this is a typical neutralization reaction between an acid and a base, and this is a very, very important reaction. Now let's see what happens when metallic oxide reacts with an acid. Here we are taking copper oxide in a beaker and adding dilute hydrochloric acid. The reddish brown copper oxide changes to bluish green solution. So Cu2O copper oxide plus HCl gives CuCl2 plus H2O. This is similar to the reaction between an acid and a base because metal oxides are similar to basic oxides. The process of dissolving an acid in water is highly exothermic, dear children. What do you mean by that? A lot of heat is produced when you mix an acid with water. So we should take utmost care while we mix an acid with water. Especially the care must be taken for mixing concentrated nitric acid and concentrated sulfuric acid with water. Acid must always be added slowly to water by constant stirring. If water is added to acid by mistake, The heat generated may cause the mixture to splash out and cause burns. The glass container may also break due to the excessive local heating. So take care while handling acids. Dear children, let's find out what happens to an acid in a water solution. When acids are dissolved in water, they give hydronium ions in the solution. See the reaction there. HCl plus H2O gives H plus and Cl minus. An aqueous solution of an acid conducts electricity due to the presence of charged particles, that is H plus in it. Now, for proving this, we have to conduct an activity or an experiment. So the materials needed for the experiment are 100 ml beaker, a core, 2 nails, a 6-volt battery, a switch, a bulb, and dilute hydrochloric acid. Now what you should do? Take the cork and fix both the nails and connect the nails using the battery, bulb, and the switch. Now place the cork inside the beaker and pour dilute hydrochloric acid and switch on the current. You will be surprised to see that the bulb glows. So this proves that an aqueous solution of an acid can conduct electricity. The same experiment can be repeated using glucose or alcohol. But in both these cases, the bulb does not glow. Dear children, acid does not show acidic behavior in the absence of water. To prove this, let's do an experiment, or let's understand an experiment. Take sodium chloride in a dry test tube and pour concentrated sulfuric acid and observe the reaction. Hydrogen chloride gas is produced. It comes out through the delivery tube. You have to test this hydrogen chloride gas using a dry blue litmus paper. It doesn't show any change in color. Now test it using a wet blue litmus paper, moist blue litmus paper. It changes its color to red. This shows that acid or hydrogen chloride gas produced behaves as an acid in the presence of water. This experiment suggests that hydrogen ions in the HCl are produced in the presence of water. The separation of hydrogen ions or H plus ions cannot occur in the absence of water. So you can write as HCl plus H2O gives H3O plus Cl minus. Hydrogen ions cannot exist alone, but they exist after combining with water molecules. Thus, hydrogen ions must always be shown as H plus ions or hydronium ions like H3O ions. H plus plus H2O gives H3O plus.